Hello viewers, welcome to Node.js Microservices from Zero to Cloud series. Today we are going to implement observability and distributed tracing across multiple services using OpenTelemetry, Grafana and Tempo, all the way from local Docker deployment to cloud. Viewers, to get basic understanding about observability, you may watch my previous video on my channel Coding Maverick. Now, in this episode, I will deploy services and API gateway on Cloudflare and Railway Cloud. So, if you have missed anything in the previous videos, you may watch this episode. So viewers, stick around and don't go away. Viewers, in today's project, we will follow the complete request journey along with observability and OpenTelemetry tracing implementation. Today's sequence would be as follows. Viewers, the client first sends a login request to the API gateway. Then the gateway forwards it to the auth service, which verifies the credentials and returns a token. That token is then stored on the client and used for future requests. When the client requests order data, the API gateway validates the token again through the auth service and then forwards the request to the order service. Finally, the order service responds with the protected data, which flows back through the gateway to client, completing the full microservices workflow cycle. Here, each service including gateway, auth service and order service will carry tracing capabilities using OpenTelemetry. So viewers, create core project structure starting from root package as Cloud Observability, and inside it create API-gateway, auth service, order service, payment service and observability packages. Now start coding in observability module. Viewers, create packages as Grafana and Tempo inside the observability module. Also create docker-compose.yml file. It should be on the root of the module. Set the configuration inside Docker file. Viewers, this configuration is freely available on my GitHub. Next, create tempo.yml file and put the HTTP listen port and distributor setting. This file is also available on the source code. Now viewers, go to terminal and run the command docker space compose space up. But viewers, you can see it has been crashed as there is no Docker installed on local machine. So first install Docker Desktop from its official website. After installation, continue without sign up. Now inside terminal, run the command docker space -- version and it is showing 24.0.6 version. Now run the command docker space compose space up inside the observability package. Viewers, there is a small issue, and that is we have tempo entry in our Docker Compose file as tempo.yaml, but our actually created file is tempo.yml. So change its extension and again run the command docker space compose space up. So viewers, when we run docker compose up command, Docker first reads our docker-compose file and identifies two services, Tempo and Grafana. If these images are not already available, Docker automatically pulls them from Docker Hub. Next, Docker creates a private internal network so both services can communicate with each other. Then the Tempo container starts. Our local tempo.yaml file is mounted inside the container, allowing the tempo to run with our custom configuration. Multiple ports are exposed, so applications can send traces using OTel and Grafana can query trace data. After that, the Grafana container starts. Grafana runs internally on port 3000, but we expose it on port 3001 so we can access the dashboard from our browser. Once both containers are running, Grafana and Tempo are automatically connected through Docker's internal network. Grafana can communicate with Tempo using the service name Tempo, not the local host. Docker Desktop backend may ask for Windows Defender Firewall to exclude its services to allow the access. Viewers, at this point, our local observability environment is fully ready. Tempo will collect and store traces, while Grafana will provide visualization and trace exploration. Now run the command in PowerShell as docker space ps. It will show the status of local running Docker instance and deployed apps on it. And viewers, you can see observability is up and running on Docker and Grafana is available on port 3001. Viewers, you can also see the Docker desktop interface, and there is also instance of observability that is up and running. So now run the Grafana UI in browser using URL localhost port 3001. Now log in the page with username and password. Give admin as username and password and skip changing password option. Now from dashboard we create Tempo data source in first step. So click on Data Sources tab, then scroll down to Tempo in Distributed Tracing section. Set the connection URL as http://tempo:3200 and scroll down to bottom. Now click Save and Test button. It shows data source is working. Viewers, in next step, we will instrument our authentication service. We integrate the OpenTelemetry SDK into our auth service, add tracing to the login and verification endpoints, and send these traces to our local Grafana instance. This allows us to see every request, each span, and the relationships between them. Now go inside the auth service package and create node project using command npm space init-y. Next install express using command npm space install space express. Then install OpenTelemetry inside the auth service. Viewers, OpenTelemetry is an open source observability framework providing a unified set of APIs, SDKs, and tools to instrument, generate, collect, and export telemetry data, such as logs, matrices, and traces. It helps developers to understand and troubleshoot software performance and behavior, especially in complex distributed microservices. Viewers, first of all, we will install OpenTelemetry API using the command npm install @OpenTelemetry/API. Next, install core OpenTelemetry engine SDK using the command npm install @OpenTelemetry/SDK-node. Next, install OpenTelemetry auto instrumentation, which is used to auto trace HTTP requests and to send traces to Tempo. Viewers, we will use the command npm install @OpenTelemetry/auto-instrumentations-node. Viewers, these are the three necessary parts of OpenTelemetry framework. Now create a file tracing.js inside the auth service for enabling OpenTelemetry functions inside the auth service. Here we import the Node SDK from OpenTelemetry, which acts as the main engine responsible for managing tracing inside Node.js application. Next, we import automatic instrumentations, which allows OpenTelemetry to automatically trace common libraries like Express, HTTP, Axios, database drivers, and many more without writing manual span code. Next, we import the OTel HTTP trace exporter. This exporter is responsible for sending trace data to an external backend like Tempo or Grafana Cloud using the OTel protocol over HTTP. Next, we import the OTel HTTP trace exporter. This exporter is responsible for sending collected traces outside our application to the systems like Tempo, Grafana Cloud, or any OTel compatible backend. Next, we configure the trace exporter. We will tell OpenTelemetry to send all traces using OTel over HTTP to the Tempo service running inside the Docker. Port 4318 is the standard OTel HTTP port, and /v1/traces is the official OpenTelemetry ingestion endpoint. Next, we create a new OpenTelemetry Node SDK instance. This is where we configure how tracing should work in our service. Next, we set trace exporter with exporter. Then we enable automatic instrumentation for the entire node application by setting get node auto instrumentation. Once this is active, OpenTelemetry will automatically create spans for incoming HTTP requests, outgoing requests, and framework level operations. Calling SDK start activates OpenTelemetry, and in the end log the message about successful tracing initialization. Viewers, from this moment onward, every request handled by this service will automatically generate traces and send them to Tempo. Now viewers, create the auth service by creating index.js file. Next, /tracing is intentionally placed at the very top of the file, before the express, before the routes, before anything else. This is required because OpenTelemetry must hook into Node.js internals before any framework loads. Next, we import Express, which we will use to create our authentication microservice. Then we create our Express application instance. Next, we allow Express to read JSON request bodies, which is required for login request. Next, we define the login API endpoint that will be called through the API gateway. We extract the username from the incoming request body. Next, we simulate authentication flow. There is no database yet. It is just for understanding tracing. We intentionally add an artificial delay to simulate real-world processing time, such as database calls or password verification. After the delay, we return a mock authentication response with a status OK, username and fake JWT token. 100 millisecond delay helps us to visually see latency in the Grafana traces. Next, we start the authentication service on port 3000. Then log message to confirm that our auth service is running and ready to accept request. Now viewers, run the auth service locally using command node space index.js, and it has showed the success logs of auth service start and tracing initialization. Now in Thunder client, set the URL and set header content type with the value application/json. Set the body with username and send the command. And viewers, you can see service has returned the data we have set previously. Now viewers, test the service with observability on. For this, first down the Docker and again make it up and run the auth service again. Then send the Thunder client post request again. Viewers, you can see Docker is running the observability instance. Now open the local Grafana UI, log in with the password. This time you have to create data source again, as when we restart the Docker, it resets everything to default. Now after that, go to Explorer and then Search tab. Then click the Run Query button from right top. Grafana UI has loaded the traces in the trace table. Viewers, trace table has trace ID, start time, service name and request name. But viewers, you can see that service name is missing from the trace. So we will set the service name along with service version for OpenTelemetry so that it may present it in every trace in Grafana UI. Viewers, easiest way is to pass them as environment variable through terminal command. It should be before the node space auth service start command. Now again open the Grafana UI and its Explorer and query the traces. And you can see Grafana has loaded the service name with every trace. Viewers, We may summarize the trace info as trace ID is for unique identification, span shows each step of the request, duration and time are for performance analysis, parent-child relationship and context propagation are for presenting relationship of multiple traces and spans. Now viewers, we will adjust our auth service to deploy it on Railway Cloud so that we can visualize the tracing in cloud environment instead of local observability inside the Docker. For this purpose, we will also link it with GitHub. This is for the Railway Cloud, which pick the GitHub CI/CD pipeline for continuous deployment of any source code. Now deploy the auth service on Railway Cloud. First click on the Create button on the right top of Railway Cloud dashboard. Then click on the GitHub repo option. Select Own repo if available. Otherwise, link it first. Viewer, Railway Cloud would pick the whole repo where multiple services may exist. So from Settings tab, add root directory where our service exists, like in our case, auth service. Change the deployment title with the auth service and click on the deploy button. Now, Railway Cloud would start deploying the auth service. After the complete deployment, copy the service URL and test it from Thunder client where we tested the local auth service. In this whole observability project, API Gateway plays a critical role. Every client request, whether coming from a browser, Thunder client, or test application, first lands on the gateway. It is the very first hop in request journey. The gateway is responsible for starting the trace. It generates the trace context and forward trace header to the downstream services. In simple terms, API Gateway becomes the root span of every request, allowing us to visualize the complete request flow across microservices inside Grafana Trace Explorer. So viewers, we will initially develop Gateway as a Cloudflare worker. So let's start with the command wrangler space init space API dash gateway and set all desired options. the creation of Cloudflare worker, we will start implementation of API gateway. So viewers, go inside API gateway module and open index.js file. And you can see the default code of the worker. First, on the top, set auth service and order service URLs. Then add course helper to avoid cross-origin errors. After that, add helper for success response. Now, create implementation to forward request to service with trace headers. After getting trace headers, forward the request using fetch method and return the response as data object. Now, go inside the export default function and remove hello world. Implement the try catch and handle browser course pre-flight requests. Return the required headers and stop the request before it reaches the main API logic. Now, forward the login request to auth service. Now, deploy the API gateway on Cloudflare by the command wrangler space deploy. And after deployment, it will return its URL. Now viewers, we will perform Grafana Cloud configuration. Go to URL grafana.com/auth/sign-in and sign in for the first time with a valid email. It will return you your dashboard session, like here it returned as shafkatgrade.grafana.net. Open it and from left panel create new connection. Viewer, select OpenTelemetry from featured section and create connection. Viewers, after connection, copy the OTLP endpoint and header key from step 4.2. Now open the auth service tracing file and link it with the cloud OpenTelemetry environment from local to cloud. Go inside the tracing.js file and change the export setting from local URL to cloud, like OTel underscore exporter underscore OTLP underscore endpoint URL. Also include header with OTel underscore exporter underscore OTLP underscore headers. Now viewers, open the Thunder client and use the Cloudflare API gateway URL. Use post command and set content type in header. Also set username in body. Now send the command. And viewers, you can see it has returned the data from Railway Cloud deployed auth service. And this data is routed through Cloudflare deployed API gateway. So now nothing is local, all running from production environment. Viewers, now we open Grafana Cloud Explorer and drill down the view from the left panel. Here you can see the trace of our request sent through Thunder client is available. So viewers, up till now we have developed auth service and API gateway. We have deployed both of them in cloud environment and viewed their traces in Grafana Cloud. Now it is time to add one more service in our project, and that is order service. But viewers, order service should only work if the user is authorized by auth service. It means API gateway would receive request from the client, auth service would validate token, and only then the order service would be allowed. Order service must never trust the client directly. Viewers, to achieve this, we also have to slightly augment the API gateway and auth service current implementations. But first of all, we need to create order service and implement tracing inside it, similar to auth service. Now viewers, we will augment the API gateway implementation. Viewers, while adding authorization in API gateway, we will first of all add standard API response wrapper to return clean JSON and HTTP response clean from coarse errors. Next, create a function to extract headers from any request. Next, create authorization function. This function will return user object if verified and authorized based on provided token via auth service. Otherwise, it will return null object. Next, we create login forward function. This is initial function to authenticate user based on email and password. This function will be used before verification process, and this function would provide token for subsequent verification for order service. Next, we create forward order function. This function will bring order details from order service to API gateway. Now, we implement the gateway core functionality using above created functions. First, create fetch function and implement pre-flight course checks. Now, inside try block, capture the URL from request, and if it is of type login, then call the first login mechanism using function forward login. It returns token to the client. In the next request, client calls order request along with the token. So in API gateway, if the request URL is of type /orders, then call the authorize function and ask for verification from auth service while providing token to it. If authorization fails, then return error message. Otherwise, call forward order function. It will call the order service while passing user identity with role inside its header. Order details would be returned based on this role. Viewers, in this gateway implementation, with every request, we forward traces to the next request using function extract headers to ensure efficient trace propagation. After the creation of order service and its integration with API gateway and auth service, now we test everything. Viewers, I have created and deployed a simple HTML JavaScript client. Source code of this client is also packed with this project and available on GitHub. This client allows us to simulate logging in, storing tokens, and calling protected endpoints on order service. Each request generates a trace that starts at the gateway and flows through all services. Viewers, open this client in the browser and click login with default test user, and viewers, it has returned the simulated JWT token. Now go inside the local storage of the browser and you can see the same stored token. You may visualize and confirm it on the front end by clicking the button Show Stored Token. Now click on Get Orders button. This action sends this token to gateway again in header. Gateway verifies it and gets authorization from auth service. And ultimately order service returns order details along with linked user details based on this token authorization. Viewers, we may enrich this internal implementation of order service in actual project. Now viewers, inside the Grafana trace table, we can see traces. Our last trace is not showing service name as root span has not yet propagated its values. But this trace is integrated trace by API gateway. It carries both actions from auth service and order service. And if we open it, we can see in the left bottom span section that both services spans are available with labels. All spans are highlighting latency and service dependencies, essential for scalable observability in any microservices architecture. However, root span is not showing API gateway name just because we may not fully implement the OpenTelemetry in Cloudflare worker, which is basically our API gateway. But viewers, we have successfully linked traces of our services through gateway for unified monitoring and debugging. And this is how we have achieved the concept of observability through distributed tracing. So viewers, that's it for today. And also the conclusion of our Node.js microservices from Zero to Cloud series. Viewers, throughout this journey, we started from absolute basics. We built real microservices, connected microservices with real databases using ORM tools like Prisma, introduced API gateways, connected services securely on cloud like Cloudflare and Railway Cloud platforms, and finally achieved full end-to-end observability using OpenTelemetry and Grafana. Understand how microservices work, how they behave in production environment, how requests flow across services, and how to debug real-world distributed systems with confidence. This is the same foundation used in modern cloud-native platforms like fintech systems and large-scale enterprise architectures. I hope this series would help you to enrich your expertise on Node.js microservices. See you next in any other exciting series. Don't forget to like and subscribe my channel Coding Maverick.